city is a complex, adaptive, and closed-boundary system that continuously transforms itself. It has been conceived as dynamic systems subject to optimization. A series of new integrative approaches have allowed advancement to reconceptualizing city as a complex system and the developing a scientific practice framed by the theory of complexity. These practices have been implemented in city management to control the city as a whole, to supervise phenomena, and to lead evolution. Especially with the explosive urban growth all around the globe, the shaping and management of the metropolitan complexity became a rising issue amongst government officials, academics, and private stakeholders. Moving away from the traditional goal of pure efficiency and communicating the need of a metropolitan vision to achieve the well-being of the citizens living in the metropolitan area became therefore essential. For this purpose, it is important to define tools to manage the metropolitan complexity using a multidisciplinary and multiscalar approach. The metropolitan cartography is the process of reading, understanding, and interpreting the territory of a metropolis using maps and spatial information technology as a decision-making support system. Metropolitan cartography plays the roles of setting up the process of metropolitan training. This process orients the urban frames based on the cultural code of each agent of the system, namely the values which drive the choices. The metropolitan cartography, through a training and decision supporting tools for coping with complexity, allows civil servants to reach the following goals: to identify, classify, and organize resources, that is, to assess environmental, cultural, and social resources; to supervise the access to human and general public rights for the urban dwellers; to identify and manage risks, that is, to increase the availability and access to disaster risk information to assess multi-hazard early warning systems; to take systematic decisions for the Metropolitan Sustainable Development Plans according to United Nations Sustainable Development Goals indicators, the new Urban Agenda Principles and Indicators, multi-level legal framework and operational norms; and finally, to evaluate the impacts of development plans and metropolitan projects and to validate their sustainability. We need a comprehensive and multidisciplinary approach to the study and practice of the metropolis. In this regard, metropolitan cartography is a necessary tool to detect a new pattern in spatial-temporal analysis, that is, urban growth determined by topography, social patterns influenced by the distribution of public spaces, the relationship between the growth or the decline of rural population and the location of economic activities, and to identify the purpose, elements, and interconnections in a city system and subsystems. It's fundamental because the rates of flow exchanged by selected interconnections determine the behavior of interest. Urbanization rate is a feedback loop of productivity. Urban workers, for example, produce more while they have to pay more in housing costs. The Metropolitan Dynamics Model is an interpreted map of the real system, namely of the metropolitan complexity, that demonstrates the intention of a project of metropolitan planning and projects. There is a finite selection of variables representing the elements of metropolitan system. They contribute to the model, the flow that represents activity within and between the selected elements. Machine-readable open data information, particularly open government data and open linked data, has generated a great excitement for its potential to empower citizens, change how government works, and improve the delivery of public services. Metropolitan cartography uses open data to boost innovation through the use of data technologies, stimulating the use of open data in the public sector through a specific data governance, and to design an effective and affordable process and technological solution to supervise identified urban phenomena. The Metropolitan Cartography uses maps and spatial information technologies to frame the metropolitan model. The maps are a logical tool to extract the operators from the real world to translate data into information and information into knowledge. From this abstract process of identification and interpretation of operators of various disciplines, it's possible to design a set of maps with the purpose of writing a collective narrative for the metropolitan dimension. Metropolitan cartography general rules are to reintroduce geography and represent the metropolitan subsystems connected to physical space. The administrative boundaries are not used as boundaries of metropolitan systems. The right boundary to think about a metropolitan issue rarely coincides with the boundary of an academic discipline or with a political boundary. For example, rivers make handy borders between countries, but they are the worst possible for managing the quality of the water. Cities have dynamic behaviors depending on the scale they are represented. Maps need to represent the system using the right scale or jumping between scales. For example, gray infrastructure that refers to the human-engineered infrastructures have a different strategic values depending on the scale. To rehabilitate the history and memory of the metropolitan space, combining spatial and temporal analysis, and to transform quantitative and qualitative data in information that can be overlapped in the spatial analysis.